All right, today we're gonna be solving a moment of inertia problem. But first, we need a problem. Got a problem now?
I need a problem statement. There's a problem statement.
Now that we have a problem and a problem statement, we can move to the next board.
Thanks, Grayson. Now we need to break this problem down into 3 parts. There you have it.
Because we're using the table method to solve this problem, here's our table. Alright, now that we got the table, we can start solving for component 1. So component 1 is going to be the top bar right here. So we're going to start solving for area. So with a base of 10 and a height of 2, it is going to be 20 inches squared. For the y bar, since the origin is in the bottom left, we're going to go up the 8 inches that is component 2, and then divide our height by 2 as well to get a y bar of 9 inches. We'll take the area and times the y bar, multiply that together to get 180 inches cubed. For the x bar, we'll do the same thing. We'll go from the origin. Since this is 10 across, we're just going to take 10 inches divided by 2 to get 5 inches. And for the ax, we're going to multiply the area times the x bar to get 100 inches cubed.
All right, Grayson took way too long, so we're gonna speed this up a little bit. There we go.
So now we're going to solve for x bar and y bar. And so here you have x bar and y bar. So how you find y bar, you're going to take the sum of a y bar, put it over the top, sum your areas, divide those two, that gives you y bar. Then you do the same thing for x bar. You get 5.66 for y bar, 5.33 for x bar.
Now that we found the centroid, let's move to the next board.
Thanks, Jesse. Now we're going to solve for moment of inertia, now that we have the centroid, using the table method. So now that we have the first row done, we're going to go into it. So for moment of inertia, on the x-axis, we've got 10, the width, times 2, the height, to the third power, over 12. With that, we get 6.66 inches to the fourth. Then moving on to dy, we're going to take the height, which in this case is 8 before we get to the first shape. And the centroid of number 1 is 2 over 2. So with that, we're going to minus the actual centroid, and we're going to come out as 3.34 inches. Then moving on to 80y, we are just simply going to take the area times this number, so it's 20 times 3.34 squared, and we're going to come out with 223.112 inches to the fourth. And then similarly, we're going to do IY, but in this case, we're going to do HB to the third. So these are switched now. We're going to have 2 times 10 to the third over 12, which gives us 166.67 inches to the fourth. And then moving on to DX, we don't have to add anything in this case because this shape is the entire width. So we're going to take 10 over 2 minus the actual centroid, which gives us 0.33 inches. And that's how far this shape centroid is away from the actual. And then finally, we're going to do 20 times 0.33 squared, giving us 2.178 inches for ADX.
All right, Garrett was a little slow on this one, so let's speed things up. There you have it.
Here you go, Garrett. Thanks, Johnson. Now we're going to start our equations for moment of inertia. Okay, so now we have our equations for moment of inertia. First, we're going to look at Ix. To get Ix, we're just going to need the sum of Ix plus AY squared. So we're going to pull these numbers from our previous table, and with that, we get 220 plus 333.336 for a total of 553.336 inches to the fourth. Similarly, we've got IY here, and we're going to pull these numbers from the last table. We've got IY plus 80x squared. With that, we're going to get 177.23 plus 543.334. Those put together is going to be 720.664 inches to the fourth.
Now we're going to solve for radius of gyration. So here you have your radius of gyration. What you're going to do is you're going to take your Ix, put it over your area that comes from the first board over there. And then you're going to take the square root of that. You're going to get 3.04 for your Rx and 3.47 for your Ry. Any questions?
Okay, now time for a recap. Here you go, Johnson. Thanks, Garrett. All right, so here we have all of our answers in review. We've got Y bar at 5.66 inches, which comes up past midway here. And we've got X bar 5.33 inches. We've got it marked here from left to right. So our centroid is going to be somewhere around here. Obviously, this isn't to scale. Then we've got a moment of inertia with IX, 553.336 inches to the fourth. IY is 720.664 inches to the fourth. And finally, we've got Greyson gyration, RX 3.04 inches, and RY at 3 inches and 0.47. Thanks for learning with us.